All right, so let's look at our last section for this week, which is 8.4. Okay, yesterday we looked at changing complex numbers in standard form to trig form, okay, for the benefit of multiplying and dividing. Today we're going to do the same thing, change them from standard form to trig form, but for the purpose of taking powers, okay, and we're going to use what's called DeMoivre's theorem, and for doing roots. Okay, so we're going to take this number and we're going to raise it to a power. Okay, so here's the general form of a, the trig form of a complex number. Okay, just a generic number. I don't know r and I don't know theta. And what I'm going to do is square it. Okay, so I'm just going to write it out twice. R cosine theta, I sine theta, times r cosine theta, I sine theta. Okay, and we're going to distribute it all out. One thing to make it a little easier to distribute, visually, let's just pretend that r is next to the other r. I'm not going to rewrite it and move it, but what would r times r be? R squared. And now the rest of it is going to be FOILed. Okay, what's cosine times cosine? So we're going to get cosine squared. We have cosine times I sine, cosine times I sine. How many of those do we have? 2 of the cosines times I sines. So we can write plus, I'm going to write it like this. 2 of the I sine cosines. Okay, that's imaginary. And now the last part, I sine times I sine. What's I times I? -1. So minus, what's sine times sine? Sine squared. All right. So now we've done out the arithmetic. All I'm going to do is regroup it, and hopefully you recognize some identities. Okay, so I've got r squared. I'm going to make it cosine squared minus sine squared, which is not the same as cosine squared plus sine squared. That's a different identity. Cosine squared minus sine squared plus 2 sine cosine. You know what? I'm going to put the I right there. It doesn't really matter where we put it, but when we simplify this all, that's where it's going to be. It's going to be in front of this 2 sine cosine. Okay, any questions on that stuff? Now from here, we have to recognize 2 identities. There's one there, and there's one there. Okay, the second one might be easier to recognize first. Does anybody remember what 2 sine cosine is? I think it's one we looked at in section 7.5. Two sine cosine. Yep.
Cosine squared?
No, not cosine squared.
Sine 2 theta.
That's sine 2 theta. Yes. Okay, so that part becomes sine 2 theta, and that part is imaginary. Now, this first part is one of 3 versions we had for this. Does anybody recognize what cosine squared minus sine squared is? That would be plus. If it was cosine squared plus sine squared.
It's cosine 2 theta.
That part is cosine 2 theta. And that's what we get when we square r cosine theta plus I sine theta. What do you notice? What happened to my radius when I squared z? My radius got squared. And what about my angle? It doubled. Right? Let's see if we can extend that pattern to z cubed. And then if we can get it for that, we'll assume it works in general. What do you think z cubed would be?
R cubed.
R cubed.
That would be cosine 3 theta
Yep.
plus I sine 3 theta.
Yeah. So r cubed cosine 3 theta plus I sine 3 theta. If I wanted to raise something to the 90th power, it would be r to the 90th cosine 90 theta plus I sine 90 theta. Right? So this gives us a very easy way to raise a number that's in trig form, has to be in trig form, to a power. Okay? And it's called DeMoivre's theorem. So the theorem works for any integer power. And what you do is raise the radius to your power and multiply the angle by your power. Right? So the advantage is if I asked you to do something like this. Actually, let's use that. 2 plus 2i. And I wanted to raise this to the 50th power. Well, if I was going to do that out without this theorem, I would have to write 2 plus 2i times 2 plus 2i. How many times? 50 times. And then I would have to FOIL everything together. Now, there'd be a lot of repeats. You'd have 2 plus 2i, and another 2 plus 2i, and another 2 plus 2i. So you might be able to FOIL the first two, and then use that answer, a few times. But still, it's going to be a lot of work. If we change this to polar, my radius is square root of 8, or 2 root 2. How about my angle if I've gone right and up the same amount? Yep, and what's the inverse tangent of 1? 45 degrees. Now, by changing it to polar, watch how quickly I can do this to the 50th power. Okay, I have r cosine 45 plus I sine 45. And to raise it to the 50th power, I might need my calculator, but it's not going to be hard to do. 2 root 2 to the 50th, okay, whatever that comes out to, times cosine 45 times 50, whatever that angle comes out to, plus I sine 45 times 50. Very, very fast way to raise that to the 50th power, and I'm done. Foiling it, you would have hundreds of multiplications to do, hundreds of like terms to combine. You're going to make a mistake somewhere. So this is the real advantage to using trig form. Okay, somebody had asked me about that earlier. All right, so we'll go through a couple problems. I'm not going to do something as big as the 50th power, but we'll try. We'll just try cubing something. Now, cubing, the advantage isn't as great. I could probably cube this by hand the way it is reasonably fast. Okay, but we'll practice with DeMoivre's theorem.
No, we have to do law.
Okay, what's my radius for this point? Yep, it's going to be 2. Square the first term, you get 1. Square the second term, you get 3. Add that together, you get 4. Take the square root. That's 2. Right, so you just use your Pythagorean theorem to get your radius. And what quadrant is that point in? First, what's my formula to find theta in the first quadrant?
Inverse tangent of y.
Okay, what's y in this case? Square root of 3. And what's x? Okay, so I need the inverse tangent of square root 3. So inverse tangent of square root 3. 60 degrees. All right, so now how would I write that point in trig form?
2 cosine 60 plus I sine 60.
I sine 60. And what power are we going to raise it to? Third power. Right. So to do that, how am I going to find my radius? Cube 2. So what's 2 cubed? 8. And how am I going to get my new angle? 60 times 3, which is 180. And if they wanted us to leave the answer in trig form, you're done. There's nothing else you'd have to do. That's the answer for 1 plus root 3I cubed in trig form. Okay, let's practice changing it into rectangular. Okay, because I think somebody had asked about that earlier. Okay, let's start with cosine of 180. What's the cosine of 180? -1. Right? 0 is at the top. 90 is at 0. 180 is at -1. Okay, so that becomes -1. And how about the sine of 180? Yeah, 0, 0. At 90, we're at the top. At 180, back to 0. All right? So what's I times 0? 0. -1 plus 0. And then -1 times 8. -8. So in this case, we actually get a nice answer in rectangular. Very nice answer. Right. So if you cube 1 plus root 3I, you get -8. How would you reverse cubing? Cube root. If you were to take the cube root of -8, what would be one of the answers? It's like if I told you to square 5 and you get 25, and then I wanted you to undo it. Right, you get back what you started with, right? If I said take 5 and square it, what do you get? Okay, you get 25. Now undo that. Square root of 25 is 5. So we took 1 plus root 3I and cubed it and got -8. Now if you cube root -8, what's going to happen? We're going to get 1 plus root 3I. We'll be reversing what we just did if we took the cube root. Okay? This is one of the 3 cube roots of -8. Okay? If you're taking a root, whatever root you're taking, there's that many answers. Square root has 2, cube root has 3, fifth root has 5. Okay? We're going to get into that a little bit more in the next part. Okay, but any question on that? Right, so we cubed 1 plus root 3I and got -8. So if you cube root -8, you go back to what you started with. Okay? Another answer for the cube root of -8, an easy answer to get, is -2. -2 times -2 times -2. And there's also one more answer, which we'll talk about. Okay, so this one, I want to raise this number to the 8th power. Yep. So what's the first thing I'd have to do in order to raise this to the 8th power using our new theorem? Because this is not ready to use the theorem yet. Yeah, you can't have it in standard form. It has to be in trig form. Okay, so we got to find our radius and our angle. Okay, what do you get if you square -√2 over 2? Yep, you're going to get you're going to get 2 over 4, or 1/2. And if you square root 2 over 2, you get 2 over 4 again. So what's my radius here? 1. Okay, now my angle. We know it has something to do with a 45 because you've gone left and up the same amount. Okay? So we've gone left and up the same amount. So what do you think that angle would be?
135.
Yeah, it is 135. If you're like, wait, I don't see how to get that. Okay. Do 180 plus inverse tangent of y over x. What's y divided by x in this case? If you did that out, it's really just the inverse tangent of -1. If you take the inverse tangent of -1, you get -45 plus 180. There's your 135. All right, so we got my radius, we got my angle. This time, because the radius is 1, I'm not even going to write it. So it's just r cosine theta plus I sine theta. And we're raising it to the 8th power. What's my new radius going to be? Still 1. Okay, it's 1 to the 8th power, which is 1. And how do I get my new angle? Times what by 8? Which is? 135 times 8. So I get 1080. Now, that's a pretty big angle. So what can you subtract from an angle that doesn't change it but makes it smaller? 360. Can I do it again?
Yeah.
Yep. And I can do it one more time. So 1080 is the same as 0. And anytime that you get angles here that are multiples of 0, 90, 180, 270, okay, or even actually anything that's a multiple of 30, we can write nice answers. The 30s, multiples of 30 aren't as nice because you have to remember if it's like a root 3 or a root 2. But multiples of 90 are even easier. There's no square roots. What's the cosine of 0? 1. What's the sine of 0? 0. What's I times 0? 0 plus 1? 1. Right. So if we raise that to the 8th power, the answer is 1. What would that mean if we think about that in reverse? Raising this to the 8th power gives me 1. Fred?
The 8th root of 1 is that.
Yeah. If you take the 8th root of 1, first of all, there's 8 answers. This is one of them. Okay? Any question on that? We're not finding the other roots here. All we're doing is proving that that is the one of the 8th roots of 1. Okay? And we've done it. All right, let's take a look at this. So I already mentioned this idea to you guys. Okay, in example 1, we cubed a number. Okay, the opposite of that is cube rooting. So if you cube this and you get that, then in reverse, if you cube root this, that's one of the answers. Okay? So that's what we're going to start to look at after the next problem. Okay, taking roots. All right, so nth roots. Okay, so what we're finding here is not necessarily just square roots, cube roots, but any root. Okay? And this is the equation that you want to set up if you want to find an nth root. Okay, let me show you why it works. Let's say I want you to find a cube root of 8. I'll show it to you with numbers. If I want to find a cube root of 8, fill 3 in for n, fill 8 in for a, and then solve the problem. So z cubed equals 8. Now, if you can solve that equation, z will satisfy the question I just asked you. What are the cube roots of 8? Okay, and if I'm going to find the cube roots, there's actually 3 answers. 2 is a real answer, and the other 2 answers, well, what do you think the other 2, what type do you think they're going to be?
Cube roots.
For cube roots, what other? So 2 would be a real answer. The other ones are going to be imaginaries. Okay? Imaginary answers always occur in pairs. So you would never have like a 3. If you were finding a cube root, you'd never have 3 answers that are imaginary. You'd have 1 real, 2 imaginary. If you happen to be solving the specific equation where you have a 1 on the other side, then you're finding roots of 1. Okay? The term for that is called unity. Okay? So if they ever ask you to find roots of unity, it just means find roots of 1. Right? So if I wanted to find, let's say, the 4th roots of 1, which is a problem we're going to do, I would set it up just like that. This is the problem to find the 4th roots of 1, okay, or unity. So next we'll look at how we do it. Okay, I'm going to show you a procedure that works all of the time. Right? Since it works on absolutely every kind of problem, it doesn't mean it's always the fastest way to do it. Okay? There are some problems I'm going to show you that I could factor and do faster. Right? So what I'm kind of showing you here is like the quadratic equation. Okay? Quadratic equation can solve any problem, even the ones that are factorable. Okay? Quadratic, if it's factorable, it's much faster to do it that way. All right? But I'd rather show you a method that works all of the time, rather than something that's a shortcut that only works sometimes. Okay? All right, so here's how we find nth roots. First thing we have to do is set up our equation. Okay? If it's not set up, n is the root you're looking for. A is what you're taking the root of. And remember, z and a can be complex numbers. Okay? We're not working just in the set of reals. We're working in the complex number system. So the first thing we do after we set up this equation is we have to translate it to trig form. Okay, now when we do that, what's on the right is going to be an actual number. What's on the left are going to be all my variables. Okay, so in this one, I'm going to have more variables than I'm really going to have because I'm not filling in a number in the explanation. Right, so in general, you're going to have an a, you're going to have a value for it. You need to find the radius and the angle for that value. Okay, just like in last night's homework. Right, so you'll have numbers for R1, you'll have numbers for theta 1. For z, you're not going to have any numbers. That's what you're going to solve for. You have to solve for the radius, and you have to solve for the angle. All right. So we have rewritten A in trig form, and we will write z in trig form generically. We're not going to know the radius, we're not going to know the angle. And then we fill those in. Fill that in for A, fill that in for z. So now I'm going to write that same equation, just plugging all that stuff into it. Right, so I've got R2 cosine theta 2 plus I sine theta 2 to the n, and that equals A, which is now in trig form. Okay, we will know R1, we will know theta 1. Now on the right-hand side, there's not really anything more we're going to do out. Okay, we're gonna have a radius, we're gonna have an angle. But on the left-hand side, I've got, it should be like this. I've got a trig number raised to a power. How do I do this part out? This is like what we just did.
Would the R to the n
R2 to the n, yep. And what about my angle?
multiplied by the
Multi- Yeah, cosine n theta 2. So the right-hand side is staying the same. On the left-hand side, we raise the radius to the power, and we multiply the angle by the power. And this is pretty much how the left-hand side is going to look, right? It's not going to be any numbers there. And now at this point, we just have to look at the equation, and we have to make what's on the left match what's on the right. Well, there's a radius on the left, and there's a radius on the right. Those two things have to equal each other. The radius on the left has to match the radius on the right. And what do you think about the angle on the left? What does it have to match? The angle on the left has to match the angle on the right. Now, what did we say you can add or subtract to an angle, and it doesn't change the angle? 360. So the angle on the left has to match the angle on the right, or anything that is coterminal with it. Okay? You can add or subtract 360. And this is where the multiple answers are going to come from. Okay, remember I said if you take a cube root, you're going to have 3 answers. If you take a square root, you have 2. This is how we're going to get the multiple answers. So the angle on the left equals the angle on the right, plus anything that is coterminal with it. Coterminal means adding or subtracting 360k, or 2 pi k. I'll do some problems in radians, but then there's one problem that's a little harder. And if I do it in radians, the decimals just confuse people worse. So I'll do that one in degrees. So when we find our roots in trig form, we're going to have a single value for the radius. But we're going to end up with multiple values for the angle. Right, so let's say we were finding a cube root. Okay, and I'll put this right back up, but just to show you an example. Let's say we were finding a cube root. How many answers would that problem have? 3. Okay, and let's say the radius was going to be 2. So I would have 3 answers. The radius would be the same in all 3 answers. They would all have a radius of 2. What's going to be different for each one is the angle. Okay, we don't know what it's going to be, and it's going to be different for each one. Okay, I didn't write the whole thing out. It would be cosine of an angle plus I sine of the angle. Okay, so you'd have 3 different angles. Radii are the same. Okay, so an nth root has n answers. Okay, how do you find the n answers? Okay, to find the answers, you're going to take what's in the second box, and you're going to let k equal different numbers. Okay, if you want to find a cube root, you're going to let k equal 0, 1, 2. That's how you get the 3 answers. So you start at 0 and go basically up to 1 less than the root you're looking for. Okay? If you're looking for a 4th root, you're going to have 4 answers. Let k equal 0, 1, 2, 3. Okay, what if you were looking for a 5th root? What would you let k equal? What would be the values for k? 0, 1, 2, 3, 4. Okay, that's how you get the 5 answers. Okay, and it'll make a lot more sense once we do it. And the nice thing is you can use this procedure every time you do a problem. It never changes. There's no tricky cases. It's just this every time. Okay, so once you get it, you really get it. Okay. I'm not going to focus a lot on drawing it, but it is kind of interesting if you draw the answers. Okay, if you graph all your answers once you get them, they're all evenly distributed on a circle of whatever radius you find. So if you were finding fourth roots, your answers might be spaced something like this. They're all equally spaced. So these would be the vertices of a square. Okay? If you were finding cube roots and you drew out your answers, it might look something like this. They'd be the vertices of an equilateral triangle. Okay? If you were finding fifth roots, they'd be the vertices of what shape? Yeah, it would form a regular pentagon. So some people that have trouble doing the algebra, they think about it visually. And they're like, well, if I have these three, I know the other one has to be equally spaced from the other two. And they kind of figure it out from that. Okay? Again, I'm not going to spend a lot of time on graphing. Maybe one question we'll graph. All right. So let's try and find the fourth roots of 1. Okay, before I start, how many answers am I expecting? 4. Yep, 4 answers. First thing I'm going to do is I'm going to write z in trig form. And it's going to be my variables. Okay, I don't know r and I don't know theta. If I did, I'd already know the answer to the problem. So z is r cosine theta plus I sine theta. Okay, we're going to raise that to the 4th power. Now, the other side, we have a number. Bless you. This we want to change to trig form. Okay. How can you think of 1? What's the imaginary part? 0. Let's graph that. How would I graph 1 plus 0i? Just go 1 to the right. What's my radius if I go 1 unit to the right? 1. And what's my angle if I'm on the positive x-axis? 0. So this one's actually not that bad. Okay, the radius is 1, angle is 0. We figured out much harder angles and radii last night. Okay, now that is going to take the place of 1. So we're changing 1 to trig form. So it's r cosine theta plus I sine theta. Okay, next step, I want to do out what's on the left-hand side as much as I can. Okay. Anybody tell me what I get when I do out that to the 4th power?
R to the 4th.
Yep.
Cosine 4 theta plus I sine 4 theta.
Yes. So r to the 4th cosine 4 theta plus I sine 4 theta. All right, now we have to make what's on the left and what's on the right match. That has to match that. The radius on the left has to match the radius on the right. All right, so let's do that first. R to the 4th equals 1. Now, in the last class, some people said just take the 4th root of both sides. That is correct. Okay, but I want you to think about it a little differently, and you'll see why in the last problem. What fraction could I raise each side to that would get rid of this 4? 1/4. Okay, when you have a power to a power, you multiply. Raising each side to the 1/4 power is the same as the 4th root. But you'll see why I'd like you to think about it this way in a minute. Well, a few minutes. Okay. So power to a power, you multiply. You get r to the 1st. And 1 to the 1/4. Well, 1 to any power is what? 1. There's my radius for all 4 answers I'm going to get. Okay, it's 1. Now I need my angle. So that has to match that plus something we have to be careful with. So 4 theta equals 0. But what do I have to add onto 0? And let's do this one in radians. 2
Okay.
k.
So now what?
Now, get theta by itself, and that'll tell us what our 4 answers for theta are. Okay. How would I get theta by itself? Yep, divide by 4. Divide by 4. So theta is going to be 2 pi k over 4, which reduces to pi k over 2. Now, we're going to get 4 answers. So what are the 4 numbers I'm going to let k equal?
0, 1, 3.
Yep. So go through each one at a time, and those are our 4 answers. All right, so let's set this up. Yeah. 4 answers, the radius is 1 for all of them. Cosine, 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 cosine. Okay. Let k equal 0. What's pi times 0 divided by 2? 0. That's my first one. All right, let k equal 1. What's pi times 1 over 2? Pi over 2. That's my second answer. Okay. Third answer. What's pi times 2 over 2? Pi. And my fourth answer. What's pi times 3 over 2? 3 pi over 2. And that's it. If they wanted my answers in trig form, those are the 4 answers in trig form. Okay, we'd be done. Any questions on getting those in trig form?
I just have a question. Where did you even get the 1 plus 0i from in the beginning of the problem?
That was given.
Oh, okay.
1 plus, if you want to add it on, you could put that in.
Okay.
But 1 was given, and there was no imaginary part, so if it's not there, you pretend it's 0.
Okay.
All right, let's change these to rectangular, and you'll see that these are all very nice answers. Okay, let's just go through them. What's the cosine of 0? 1. What's the sine of 0?
0.
Okay. What's the cosine of pi over 2?
0.
And the sine of pi over 2? 1. The cosine of pi? -1. The sine of pi?
0.
Yep, 0. Cosine of 3 pi over 2?
0.
Yep, back to 0. And the sine of 3 pi over 2? -1. All right, so we're going to get very nice answers here, okay, for all of these. I times 0 is 0. 0 plus 1 times 1. 1. So the first answer is just 1. Second answer, I times 1 is I. What's I plus 0? I. And what's I times 1? I. Okay, I times 0 is gone. -1 times +1. -1. And the last one, 0 plus -i. -i times 1. -i. So these are the 4th roots of 1. Okay? So in other words, if you raised any of these to the 4th power, you would get 1 as the answer. 1 times 1 times 1 times 1. That's 1. Negative 1 times negative 1 times negative 1. That's 1, and the other ones as well. And if you graph them, okay, this one's easy to graph because it's just 1 unit in every direction. The first one is 1 unit right. How about I? 1 unit up. How about negative 1? 1 unit left. And negative I? Yeah. So you get the vertices of a square. All equally spaced. How many, if you wanted to think about it in degrees, how many degrees apart is each answer? Yeah, they're all equally spaced. They're all 90 degrees apart. For an equilateral triangle, they would all be 120 degrees apart. Okay? So you can kind of use those facts if you get stuck to figure it out. All right, any questions on that? All right. Okay, next one, I want to show that this is an 8th root of 1. Okay, it's kind of like if I said to you, prove to me that 5 is the square root of 25. How could you prove that to me? Prove to me 5 is the square root of 25. Square 5 and hope that you get what I started with, 25. So we're going to take this, cosine 2 pi over 8, plus I sine 2 pi over 8. We're going to raise it to what power? We're going to raise it to the 8th power. And what are we hoping to get? Oops, put my parentheses in the wrong spot. So when we raise that to the 8th power, what are we hoping to get? We're hoping to get 1, right? We're proving that this is an 8th root of 1. Okay, so if I said to you, prove 5 is a square root of 25, you would hope when you square 5, you get 25. Well, I'm going to hope when I raise this to the 8th power that I get 1. All right, so what's my radius? Corey? One. And then when we do 1 to the 8th power, what do we get? Still 1. Okay, so my radius is 1. What about my angle? Well, Tom, what's my angle here?
2 pi.
Yeah, take what you have and multiply by 8. Okay, so 2 pi over 8 times 8 is just 2 pi. I sine 2 pi. And what are we hoping this comes out to? 1. What's the cosine of 2 pi? 1. What's the sine of 2 pi? 0. I times 0 is 0. 0 plus 1, 1. So we just proved if you raise this number to the 8th power, you get 1. So that must be one of the 8th roots of 1. We're not going to find the other 7, but I just wanted you to prove that one case. All right, so the last, we have 2 that are easy and then 1 that's a little harder. Let's do the harder one first, and then if we have time, we'll go back and do one of these easier ones. All right, z to the 5th equals 1 plus I. Who can tell me how I write z to the 5th using DeMoivre's theorem in trig form? Yep, r to the 5th.
Cosine 5 theta
Good.
plus I sine 5 theta.
Yep, perfect. R to the 5th, cosine 5 theta plus I sine 5 theta. And now on the right, we have to change this to trig form. Okay, 1 plus I. How do I graph 1 plus I?
1 to the right and
Yep.
1 up.
1 right, 1 up. So that's 1, that's 1. If I wanted to find my angle, it'd be inverse tangent of 1 over 1, which is how much? Yeah, so my angle is 45. And what's the hypotenuse in a triangle where both legs are 1?
Square root of 2.
Square root of 2. Now just write that out in trig form. Okay, r cosine theta plus I sine theta. Now, what's going to be my equation to find my radius? What equals what?
R to the 5th equals square root of 2.
R to the 5th equals square root of 2. And now here's where I want you to think about square root of 2 as a fraction, fractional exponent. What's another way to write square root of 2? 2 to the what power?
2 to 1.
2 to the 1/2. Now, what power would I raise each side to cancel out a 5?
1/5.
The 1/5 power. So multiply power to a power, you get r to the first. And what's 1/2 times 1/5? 1/10. Now, if you don't want to write it as a fractional exponent at this point, that's fine. What would 2 to the 1/10 be the same as?
Would that be the 10th root of 2?
That's the 10th root of 2. Okay, and I think that's how your book puts it, so we'll do it just like that. But I think conceptually the easiest way to get r by itself is to think of it as fractional exponents. If you think of it with the square root sign, I think you're going to get confused. Right, now what's my equation to find my 5 angles? What will 5 theta equal?
0, 1, 2, 45 plus 2 pi k.
Yep, we could do 2 pi k. I'm going to do degrees this time, otherwise the answers come out messy, and I think it confuses people worse. So let's do plus 360k this time. And how do I get the 5 on the other side? Divide by 5. Okay, so we get theta equals, what's 45 divided by 5? 9. And 360 divided by 5 is 72. So we're not going to get nice angles here. Okay, so we're not going to change this to standard form. We're going to leave it in trig form. What are the 5 values I'm going to let k be?
0, 4.
0 through 4. Okay. The 10th root of 2, that's my radius each time. Okay, so write that 5 times. Now I just need to find my angle 5 times. Okay, I wouldn't give you one on the test that's probably more than a 3rd or 4th root because it's not hard, but it starts getting very time consuming if you have to do like 7 or 8 of these. So right, let's do the first one. Let k equals 0. 72 times 0 plus 9.
90.
So your first angle is 9 degrees. And now basically after that, you're just adding a multiple of 72 each time. 72 times 1 plus 70 plus 9. 81. Okay, now you're going to do 72 times 2 plus 9. 153. Okay, now you're going to do 72 times 3 plus 9. Okay, so just add 72 again. 225. And now you're going to do 72 times 4 and then add 9. Okay, so just add 72 again. 297. Now, that was the last one. Okay, let's see what happens if you accidentally did it one more time. You get 369. What can you subtract from that to make it smaller? And look what you get. 9. Now you've just repeated the first answer. Okay? So all the angles that you get are always going to be between 0 and 360. If you've gone beyond 360, you've repeated an earlier answer. Okay, and that's probably as tough as they get. That's because the radius is kind of weird. The angles aren't nice numbers. Okay. All right, so any questions? These were the 2 easier ones. Does anybody want me to do either one of those? They're both cube roots. Or even if we don't do it, does anybody want me to start one of them just to see how to start it? Cube roots of -1, cube roots of -8. There is a cube root on the test. Anyone have a preference, either one? The -8? Okay. Now this time they don't even give me the equation. What's the equation that I would set up here? Yep. And as Graham said, if you want to think of it as 0i, that's fine. Okay, on the right, I'd have r cubed cosine. What would my angle be?
3.
3 theta, good. And now you need -8 in trig form. That's not as bad as the last one. That's a much easier angle. Where's -8? 8 to the left. So what's the distance from there to there? 8. And what's my angle? 180. Okay, so this would be 8 cosine 180 plus I sine 180. Okay, and the last part I'll set up, and I'll leave the rest for you unless anyone wants me to keep going. You say r cubed equals 8. That's one equation. And 3 theta equals 180 plus what? Yeah, we're using degrees here, so we would add 360k. What's the cube root of 8? 2. There's your radius for each answer. Divide everything by 3. What's 180 divided by 3? 60. What's 360 divided by 3? 120. Okay, and k will equal 0, 1, 2. So actually, I can tell you what your angles would be. They would be 0, they would be 180, and they would be 300. 0, 180, 300. All with a radius of 2. All right, so not something we're really going to spend any more time on. This is the only lesson we practice finding roots. As far as applications, we're not going to do any other applications with this. Okay. All right, so the homework tonight will be just these few problems in the book. 2, 4, 7 through 11 odd, 26, 28, 35. And I'll give you page 1 of the test. Okay, I will be after school today if anybody needs extra help. We can go over this tomorrow at the beginning of class. And then I'll give you the remaining part of the test in class tomorrow. Okay, just a quick correction on that last one. When I said the angles for, let's see, for this problem, the angles would be 60 Okay, when you do 120 times 0, that's 0 plus 60 is 60. Okay, and then the next one, 120 times 1 plus 60 is 180. And then the last one gives us 300. Okay, so again, those would be your angles. 60, 120 times 1 plus 60, which is 180. And then 120 times 2 plus 60, which is 300.